Hey everyone, let's knock out a trig substitution example. When we see an integral like this, we should notice the t squared minus 9 term means that we're going to be letting t equal 3 secant of theta. And so that means that dx is going to equal 3 secant of theta tangent of theta d theta. That's a substitution you need to recognize immediately, again, based on that term inside the radical. So that means that our integral is going to wind up being dt over t squared is going to equal, well, we've got, so I guess dx really should be dt, shouldn't it? Instead of dt, right, we're just going to write this 3 secant tangent. And then I guess instead of t squared, we're going to have 9 secant squared of theta. And the square root's going to be 9 secant squared theta minus 9. Right? When we simplify everything out, we notice that this term inside the square root is actually just 9 tan squared theta, right? So when we take the square root of that, we're just going to be left with 3 tangent of theta, right? So we're going to get 3 secant of theta tangent of theta d theta over 9 secant squared theta times, again, 3 tangent of theta, right? The square root of 9 tan squared. Right, and a couple of things are going to cancel out, right? This 3, this tan theta, that tan theta, actually that. And really, all of that's going to reduce pretty nicely to what looks like just 1 over 9 secant of theta, better written as 1/9 times the integral of cosine of theta d theta. Right? 1 over secant, 1 over cosine, is just cosine. Well, that's an integral. That's not so bad. 1/9 sine of theta plus c. Now remember, we're not done. We did the hard part pretty much because we did the substitution, we did the integration, but we still need to unsubstitute in terms of t. Well, when we draw our triangle, I'll draw it right here. This is our angle theta, and we know that t equals 3 secant of theta. That means that secant of theta equals t over 3. Well, secant is hypotenuse over adjacent. So I guess that means that here we're getting the square root of t squared minus 9, which again you might notice was the term that we had originally, why we needed to do the trig sub in the first place. So from here, we can say, okay, great, this is going to equal 1/9, and then what's sine of theta? Maybe we'll keep this in green, just to be clear that the 1/9 stays from before, but then I'll put this in red so you know that I'm using the triangle. Sine of theta is opposite over hypotenuse. And maybe a slightly nicer way to write that would be, keep writing plus instead of minus, I don't know what the problem is. That if you want. Okay, so that's just a basic trig sub problem. Definitely something you should know how to do.